Good morning, everyone. Myself, Palden Tamang of Namchi Government College of BSc second semester. Today, I would like to explain you on the topic Lorentz transformation. Lorentz transformation was named after Hendrik Lorentz in 1895, and in 1904 he derived a mathematical expression which accord for his concept. He developed a conceptual description involving time dilation and length contraction. After looking all the concept, the breakthrough was all Einstein and were so original that no one had seriously considered them before. Principle of Lorentz transformation. The transformation equation of Hendrik Lorentz relate two different coordinate systems in an initial reference frame. There are two laws behind Lorentz transformation, that is, relativity principle and light constant speed. Theory of Lorentz transformation. Lorentz transformation is the relationship between two different coordinate frames that moves at a constant velocity and are related to each other. The name of the transformation comes from a Jute physicist Hendrik Lorentz. There are two frames of reference which are initial frame motion with a constant velocity. The formula of Lorentz transformation consists of six parameters. The formula is given by T dash is equals to 11 minus Bc square into T minus Bxc square. Here T equals to time in coordinates of one prime frame, T dash equals to time in coordinates of the prime of the second frame. 11 minus b c square is Lorentz factor. B equals to speed of prime frame with respect to the unprime frame along the axis. C equals to speed of light. X is equal to axis of unprime frames. X dash is equals to 11 minus bc square into x minus bt with same measures. Derivation of Lorentz transformation. Here, S and S dash are two initial frames out of which S dash is moving related to frame S with velocity v along the positive x-axis. Initially at time equals to t dash equals to 0, the origin O and O dash coordinates. Now, let there be a point source of light at the origin O. The wavefront of light emitted at t equals to 0 when reaches a point P. The position and the time observed at 0 and 0 dash are x, y, z, t and x dash, y dash, z dash, t dash respectively. X by lambda equals to lambda x minus lambda x t plus vt dash, and we can write vt dash equals to x by lambda minus x lambda plus lambda vt. T dash equals to x by lambda v minus lambda x by v plus lambda t. Now we can write lambda t equals to lambda t minus lambda x by v 1 minus 1 by lambda square. equation number 3. And we can apply second postulate. According to second postulate, x is equal to ct, x dash is equals to ct dash, where c is the velocity of the light. Put the value of x and x dash in equation number 1 and 2, and equation becomes c t dash equals to lambda ct minus vt. Now we can take t common, therefore the equation becomes ct dash is equals to lambda t c minus v, equation number 4. Now ct is equals to lambda ct dash plus vt dash, and now take t dash common, the equation becomes ct equals to ct dash c plus v, equation number 5. Now multiply equation 4 and 3, we get ct square into ct equals to lambda t c minus v lambda t square c plus v. T dash and t dash cancel out, the equation becomes c square equals to lambda square c square minus v square. 1 by lambda square equals to c square minus v square upon c square, equation number 6. 1 upon lambda square equals to 1 minus v square c square, and we required 1 minus 1 by lambda square. 1 minus 1 by lambda square equals to v square c square. Now put the value of 1 minus 1 by lambda square in equation 3. The equation 3 becomes t dash equals to lambda t minus lambda x upon v into v square by c square. Now we cancel out v, and the equation becomes t dash equals to lambda t minus lambda xv upon c square. Now take lambda common, t dash equals to lambda t minus xv upon c square. We can determine the value of lambda by equation 6, and above equation t dash equals to lambda t equals t minus xv upon c square becomes equation number 7. 1 by lambda 2 equals to 1 minus v square by c square. 1 by lambda 2 equals to c square minus v square upon c square. Lambda square equals to 1 upon c square minus v square upon c square. Or we can say that lambda square equals to 1 by 1 minus v square by c square, and lambda equals to 1 by root over 1 minus v square c square. Now put the value of lambda in the equation number 7, and t becomes t dash equals to t minus x v upon c square upon root over 1 minus v square by c square. This is Lorentz transformation equation, and in other frame t dash is replaced by t is replaced by t dash, v becomes negative. Now t equals to t dash plus x dash v upon c square upon root over 1 minus v square c square. This is second Lorentz transformation equation. Now Put the value of lambda in equation 1 and 2. The equation 1 becomes x dash is equals to 1 minus vt upon root over 1 minus v square c square. This is the third Lorentz transformation equation. Again, x dash is replaced by x and v becomes negative. Now, x is equals to x dash plus vt upon root over 1 minus v square by c square. This is the fourth Lorentz transformation equation. These are the relation of Lorentz transformation. Advantage or merits of Lorentz transformation. It makes the velocity of light the same with respect to any two bodies which are moving uniformly relatively to each other, and more generally that it makes the law of electromagnetic phenomena Maxwell equation the same with respect to any two such bodies. Disadvantage or demerits of Lorentz transformation. So, limits of Lorentz transformation might hold good for x coordinate where x minus bt equals to 0. And as we are taking the case where x is less than c, so in a way we can extend the statement to say that the limit was exists for coordinates where x minus ct is equal to 0 or where x is equal to ct, and not for any point where x less than ct or x greater than ct. Applications of Lorentz transformation. The world line of the speed of light was kept constant by the relative contraction and expansion of the space-time coordinate system. When an object in motion is observed from a different coordinate system, the Lorentz transformation is integral to calculating its various attributes. Various Lorentz transformation provides an insight into how bodies move as well as topics such as length, contraction, time, dilation, and relative mass.